Okay, so welcome back. This is part 3 in our series where we're showing you how to develop this application here, which is a C# Visual Studio application where we are grabbing data from temperature sensor on our computer using this Libre Hardware Monitor. We showed you about that previously. And what we're doing is we showed you in the part 2 video how to grab one value from all of the sensor data that's available to us. And we're displaying that value every second. We're updating every second. And what we're going to do in this video is going to go to the next step, and we're going to take that changing data and we're going to show you how to develop this scrolling chart that is charting that data in real time. And we are using, as we mentioned before, we're using what you see here, the Libre Hardware Monitor library. And we developed a blank C# application before referencing that NuGet library. And you can see here we've got all of this data available, and we're measuring this temperature of the AMD Ryzen 7 1700. And you can see that it says here 39.4, 39.1, and it's matching almost exactly what we are grabbing in our application. And we are going to show you how to do this charting, the scrolling chart. And this Libre Hardware Monitor application also has a charting feature. And you can see here, this is the charting the same data. But if you notice, and one thing we're going to talk about before we get into how to do this, is one of the challenges when you're using free and open source software. And you can see that these charts don't really match. Here's 50 degrees, and these are peaking on mine at 50. Here it's going up to maybe 46 or 47 at the same time. And these just aren't matching, but mine is matching the actual data coming from the sensor. So this is one reason I mentioned before that I'm kind of try to avoid free and open source software, because you get into issues like this where the data can be wrong, and really, honestly, people who do free and open source don't really need to take responsibility for the data, right? They just do what they think is fun. So in this case, the data, I'm peaking up at 50 and this is down at 44, 45 at the same time I'm up at 50. So there's clearly some issues here with the plotting. The data that they're getting is correct, but the data that's going to the plot is off, and it can be off like 5 degrees centigrade. So again, there's some issues with this, which is another reason why I prefer to write an application myself so that I can verify and make sure it's right. So what we're going to do in this video is we're going to show how to do this chart, this scrolling chart, and we're going to look at some core issues inside of this application and try and understand a little bit more what's going on under the hood, how we're actually gathering this data, where's it coming from, and how are we gathering it. So here we are in C# Visual Studio Windows Forms application like we had in the previous video. Now, before we start, it's really, really important that you remember that in order to access some of these sensors on your hardware, you will have to be in administrator mode when you start up Visual Studio. You can see over here on the top right, it says admin. That's because when I started Visual Studio, I said run as administrator. So make sure you do that, because access to these sensors can be limited to people with administrative privileges. So you might, get garbage data coming out of the sensors when in fact it's only because you don't have administrative privileges. So keep that in mind. It's very important with any time you run an application doing the sensors or you're developing in Visual Studio, you got to run as administrator. I've made a couple of changes to this UI. We had a text box where we were showing the real-time CPU temperature. I got rid of that and replaced it with a couple of labels. Okay, so the top label, label 1, is going to have the real-time temperature, and this bottom one, label 2, is going to have the maximum. It's going to keep track of the maximum CPU temperature. And here I've just drag and dropped a chart. And I've got a start button and an exit button. So really basic UI stuff. I'll assume you know how to do that. If not, take a look at some of my other videos. We talk about charts. We talk about how to start your first C# application. So here is our Form 1. And as we had before, we have added the Libre Hardware Monitor library from GitHub. So we showed you how to do that in the previous one. So I've got a using statement, Libre Hardware Monitor.hardware. And then we've got the using system collections.generic, because we're going to have lists of values we're going to send to the chart for the scrolling chart. System Windows Forms, data visualization charting for the charts. So this is basically very similar to what we had in the previous video. As you'll recall, when we started that previous application, we grabbed some sample code from the GitHub repository, and it had this public class update visitor. So this is no change from what we had before, just copy and paste that class from the GitHub repository. And then here we've got our basic application. We've got, as I do normally, we've got some regions with methods. We've got two methods, one to configure the chart and one to do the monitoring, grabbing the data every second, as we showed previously, the same method. We're just going to tweak it a bit. And then we've got some event handlers. Of course, the start button, we've got the timer. We're going to have a 1 second timer. You can change it to whatever you want. And then an exit button. So here on our WinForms, we've got our, down here, we drag and dropped our timer, and you can see it set an interval of 1000 milliseconds. The first thing, we're going to have some parameters we're going to specify. And as I do for my charts, always I've got X vals and Y vals. And these are going to be the time values, and the Y vals are going to be the measured sensor values. And we're going to use list of floats. All of these are float values from the sensors, so just keep that in mind. And then we're going to keep track of the time. We're not going to grab actual time. We're just going to have like a relative time. And we're going to start out at time 0 and just increment that every time step. We're going to set the Y maximum. When we calculate what's the maximum, each time we get a sample, we're going to compare it to the previous maximum. And if it's greater, it's going to be the new maximum. So we're going to start out with 0. And then the Tmax is the time that we want to show in the window of the scrolling chart. And here this is saying I want a 5-minute window of scrolling data. You can change that however you want. So those are the properties. Form 1, the standard initialized component, and I've added a configured chart just to set up our chart. So configured chart, we've done this many times before. We're going to have a chart type .line. The thickness of the line we're going to chart is 3 pixels. And then we're going to set up the axis X and axis Y. The minimum is going to be 0. The maximum is going to be Tmax, which in our case, we're going to have 5 minutes. So we're going to have it always show 0 to 5, and it will scroll in that 5-minute window. We're going to set the label style format to F1 with only 1 decimal point. And then the axis Y interval is going to be 10, in this case, degrees centigrade. And the format, again, is going to be 1 decimal point F1. So setting up the chart, pretty straightforward. And then here is the monitor method, which actually does the grabbing. And it's going to set each value. It's going to add to these X vals and Y vals each time step, in our case, every second. So let's look at the button start. Basically, all that does is going to enable the timer, and so every 1 second, it's now going to jump down to this timer 1 tick. And all that's going to do is it's going to run this monitor method that's going to grab the data. And once it's grabbed the data, it's going to chart it. And we're going to use points.databindxy with the X vals and Y vals. Again, I do this every time I do charts, the same thing. So look at my previous chart videos on how to do charts. But pretty straightforward. And then the exit is just disabling the timer, which you don't really need to do, but anyway, and then application exit. So here is our monitor method. And as before, we've got this computer object that was in the sample code from the Libre Hardware Monitor code. And we've said, is CPU enabled true only for the CPU? All the rest of these we're going to do false for now, because all we're doing is we're grabbing from the CPU. I'm setting up a float T-val and Y-val, and as in the sample code, computer.open, computer.accept, new update visitor, which is using this class. And then here is what I've changed in order to grab the data. For each iHardware hardware in computer.hardware, which is what we had before, we're going to grab a sensor that specifies the CPU. In our case, it was called T-control and T-die. So it's basically the AMD Ryzen terminology for the core temperatures. And what I'm doing is I'm using this array.find because hardware.sensors is an array of sensors that is being grabbed. And what I'm doing is I'm doing find inside that array an item where the item.name contains T-die. So that is hopefully going to grab the CPU die sensor so that we can access it. All right, we can access the value. So this is a quick way. You could step through, like we had before, step through each sensor and see if it's the right one. But here you can just do an array.find to make it a lot easier. And if you want to add other things to this, if you want to grab other data, you can just copy and paste this and change it. One thing you will need, and we can talk about later, is you're going to need to know the name of the sensor that you want to grab values from. So we know this one is T-die, but we're going to talk about in the future how to grab all of this data, all the hardware names and all the sensor names, and send it to a file that you can review like a CSV file and see, okay, what is the name of the thing I want to grab? But here we're going to assume we know the name is T-die, and it's going to give us a sensor. Now, if the sensor is not a null, we got to make sure we don't get a null value here. Then we're going to, in that label 1, we're going to say sensor.name with a colon, and then sensor.value, get value or default. Now, the value coming back is nullable. So we're going to have to use this get value or default for this null. You can see it's a nullable float value. So we're going to use sensor.value, get value or default, and convert that to a string with an F1. So that's how our readout on the top is going to say CPU temperature, and it's going to say what the actual value is, and update it every second. Now, if sensor value has value, since this is a nullable, if it does have a value, we're going to go through and we are going to first convert the time value from seconds to minutes, because what we're going to do for the time value, we started out at 0 time value, and each step we're going to increment by 1. All right, so the time value is going to be in seconds. So we're going to divide that by 60, which is a floating point, and that's going to give us a time value in minutes. And then the Y value is going to be sensor.value, get value or default, and that will give us the time and the value. Now, we can also calculate, once we've got that Y, the sensor temperature value each second, we can say, okay, is it greater than Y max? If so, replace Y max with this new value because it's higher. So if it is higher than the existing Y max, we'll say Y max equals this new value, and then put that in the max label. Very straightforward. Once we've got that, we can now add the Y value to our Y vals that we're going to plot. Now this last set of code in the method is so we can scroll. So we're going to scroll the chart if the time value exceeds the desired maximum chart time window. In our case, it's like 5 minutes. If the time value does exceed, the list of xvals will stay fixed from 0 to Tmax, right? So that the xvals will always be from 0 to 5 once we've exceeded that 5 minutes. And only the Y vals will change with new values. That allows the chart x-axis to remain fixed at 0 to Tmax as it scrolls. So, as we talked about previously, if we want to scroll, we have to remove the 0th element of the Y vals. If T-val is greater than Tmax, we've exceeded the 5 minutes, we want to scroll, we just remove the 0th element. If it's less than this 5 minutes, we just add the T-val that we're calculating to the X-vals, and then we're all set. So once you've exceeded that, we're removing the Y vals, but the X vals stay fixed from 0 to 5, and it's always the same amount as we're going to have in the Y valves, because we're adding a Y valves and removing it. So we should always have the same number of X valves and Y valves. So that's basically it to grab the data and to scroll it. Here we're incrementing the time, and then as we had before, computer.close, that was in the sample code. And that's about it to get this scrolling value from the sensors. Now, as you can imagine, it's going to be pretty easy now to find other data from the sensors as long as we know what the name is of the sensor. And next we're going to do is we're going to look at how you can go back and find the name of the sensor that you want to monitor. So now that we have our app ready and running, you can see here we've got our core temperature 39 and we're charting it. It's really important in the engineering world that you verify that you're right. Don't just assume you're right. So what I've done is I've started up another application, a free application called Core Temp, where you can use HW Info or whatever you want. And we can compare the readings in real time versus what we got. And you can see down here, temperature readings, CPU 0. And here it says 41, 40, and it's hanging around 40, and they're basically matching. This doesn't give you one decimal point, but ours does. But they're all around, exactly around 40 degrees. So you can see we've got some other verification that our data is good. So in the engineering world, it's really important that you don't just assume, you verify and make sure that you have the good data. So now the question becomes, where does all this data come from? I mean, we got tons and tons of data from all the components, the motherboard, the CPU, the RAM, the storage, the fans, what's the fan speed? Where is this data all coming from? And we're going to start to look at what's called the Super I/O chip, which gathers a lot of sensor data that you can access, and we're going to see how that all works. And we're going to see what's going on under the hood so that instead of relying on a library, maybe we can write our own code to access it directly and understand a little bit better what's going on with all these sensors, where are they located, and how do they work. So that's it for this one. If you're liking these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.